What's up, Jordan? Good to see you again.
Yeah, likewise. Thanks for having me on.
Anytime, anytime. You've been a repeat guest on various podcasts, so it's awesome to have you back. Yeah, so I don't know that you need much of an introduction. You've been on the show before. So what did we pick up last time? I think small data is something we can always talk about. What's been on your mind? I mean, I kind of joke you were one of the OGs of big data. Now you're one of the OGs of small data. Why is small data so interesting to you?
I think one thing is that I feel like people who are practitioners sort of get it kind of viscerally that most of what they do kind of the scale of the data is not the kind of the most important part of it. Whereas I think a lot of vendors still feel like their job is to sort of push the scale and make things work with bigger and bigger data sizes. Um, and to the point where it's like the world that they live in, the world that users actually live in, kind of are now like two separate places. And I like to use this sort of the first time that this like actually kind of landed with me was when um, Snowflake and Databricks had this like this benchmarking wars. This was like a couple of years ago now, and um, they were Databricks said we're faster. Snowflake said no, you did it wrong, and then anyway. But if you look at the fine print, it was like they were the data sizes that they were using were like 100 terabytes, and like 100 terabyte, and that's like 100 terabytes of like data that actually gets like scanned during the queries. And it's like that just is out of the realm of kind of what most people, almost everybody actually does. And that was, after having, worked on BigQuery with some of the largest customers in the world,
Right.
like Walmart and HSBC and Equifax and like, you know, Home Depot, like these were like giant customers, and they have giant amounts of data, but in general, like most of the data is just sort of sits there. So I wrote a blog post called big data is dead, and sort of been talking about that for a long time. And I think one of some interesting things recently, the folks at Redshift uh, published a data set to sort of back up a paper that they are doing on sort of data sizes. And first of all, they were saying is like the TPC benchmarks are fundamentally broken, which is great to see somebody saying that, because everybody in database who's building databases, like they run these benchmarks and they say, hey, look how fast we are on these benchmarks. And these
Hmm.
benchmarks don't actually relate to kind of the workloads that people actually do. So it's good to see like somebody kind of agreeing with that and focusing on that. And the other tricky thing is that if you're a vendor, it's hard for you to say, hey, these benchmarks suck, because it looks like you're just saying like, oh well, we're not good on these, so you should use a different benchmark. Uh, and so I think hopefully there's some growing interest in a different way of measuring database performance. Incidentally, kind of when we started working on MotherDuck, uh, we I became aware of, I saw a talk by Leilani Battle at the University of Washington, and she had an interesting way of measuring database performance, in a particularly that was interesting for small data, which is um, instead of like trying to figure out, like summing up the time that a bunch of these queries run, it's how many of these queries run in under a second. I
Hmm.
think if you're a user and you're kind of an end user and you're have a dashboard, it's sort of like this threshold of interactivity is the important one, versus like if you database X takes 5 milliseconds and database Y takes 25 milliseconds, that's a 5x difference. On one hand, that's meaningful. On the other hand, if you're a user, those are indistinguishable. And
Right.
so kind of um, there are a lot of cases where sometimes certain queries are much slower, and I think that's one of the things that's important to it had to be. So anyway, back to the Redshift data set. Sorry if I'm going a little long on
Oh
this.
no, no,
It's
it's great.
it is one of my most favorite topics. So they published this data set that showed like 500 million queries on Redshift. I think 200 different Redshift instances over 3 months. and kind of it showed, query performance, memory usage, like a whole bunch of just really interesting statistics. They made the data set public. They put it on S3. And it's so very nice that you can, the conclusions in their paper, they actually sort of back up with real data. But so for me, that was interesting in just sort of trying to understand, okay, well, if you're using Redshift, which is a big data tool, how much of that data is actually big data, and how much of that usage is actually big data? And, so one of the things that they're very clear about is that this data is not representative of like the overall fleet. On the other hand, like they didn't choose these because they were small and like easy to like, they chose these because they were sort of big active data sets. And so looking at the data, again, you sort of see that most Redshift users don't have massive amounts of data. The ones that do have massive amounts of data tend to use smaller amounts of data.
Right.
And then even when they do run queries against their large tables, they only query small slices of those tables, which, in general, like if a well-partitioned data set, you might have 10 years worth of logs, but if you only look at the last 7 days worth of logs, you don't really need big data tools to be able to handle that. Because, in this day and age with separation of storage and compute, if you're only querying a small part of a large table, like you don't need sort of massive, computational capabilities. So anyway, that was a long-winded thing. And then just finally put in a plug
Yeah,
for I think there's a lot of people that are interested in small data, and the people that have come up to me after publishing that and say, hey, we don't have giant amounts of data, or like this is consistent with kind of what I see. So we are hosting a conference next month in San Francisco called Small Data SF for people who are who believe that that the small data is important, and small can be mighty, and the goal is to be a little bit tongue in cheek, a little bit sort of poking kind of fun at the big data conferences like Big Data London, and everybody talking about how building these giant systems, and we can just talk about, hey, I've got small data, but I want to make it easy to use, and I want to get actual work done.
That's funny, actually. I think I am at Big Data London at the same time you're doing the Small Data Conf. So, because I think Ryan asked me if I wanted to, actually I'm in Australia right then, but yeah, it's pretty funny because Ryan Boyd, he's like, you should come hang out with us. I'm like, I wish I could, but I'll be at the Big Data one. So sorry. No, that is an interesting one. I mean, do you get the sense that people kind of think that you're kind of a big data trader in a way?
Maybe I think some of the database people do. It's like, hey, you were on our side and now you're not on our side anymore. Yeah, I did a lot of like big data, data stuff. I used to on BigQuery would get up on stage and query a petabyte, live, and say, hey, look how fast this is. And the thing that I didn't tell people, was that this is a $5,000 query. And I think that's also one reason that most people don't. One of the reasons most people don't query massive amounts of data at once is that it's expensive. Like, I think these large scale systems were able to make querying large data fast or faster, but they weren't actually able to make it inexpensive. And so, I think in general, people, try to find different alternatives.
Yeah, I was talking to a friend of mine at GCP actually last week, and without reviewing too many details, I'm sure you know the drill. But yeah, he'd helped a customer get set up on BigQuery and had them specifically told them to use a cluster key that he showed them to use. And then in their infinite wisdom, they decided not to use the cluster key, and they ended up doing full table scans on many terabytes of data. And I think their bill ended up being like $85,000 for a month or something crazy like that. Just because of the small detail, we probably don't need that key that he told us to use. So you could mess yourself up pretty easy if you don't know what you're doing.
Yes,
or if you ignore best practices.
Absolutely, and that was something actually that I think was one of the things that the knock against BigQuery for a long time was that it was easy to accidentally spend a lot of money. We had like grad students that were running things in a loop over the weekend and running up $2 million bills.
What?
Yeah, I think they're still working in the Google salt mines to pay off their debt. But
Jeez.
someday they'll get out and have a good story to tell about it.
Oh my God, that's gnarly. Um, but I mean, so when we talk about small data, I mean, so you give instances where you're talking about you may have small data to begin with, and it's just small. You may have big data sets, but you're only querying a subset of those. Is that how you distinguish quote small data from big data? Is it just the intention of what you're trying to do with the data?
So that's it's a great question. It's a great distinction because I think very often, like I hear people say, like, well, we're in the big data 1% because we have all this data. We have like a petabyte of data. Or we have 10 petabytes worth of data. But I think big data is more about kind of how you're using it. And I kind of mentioned like separation of storage and compute. Like if you have, like the kind of the relevant size is not really the total size of your data, because like in BigQuery or in most databases, like you often have databases. Your data is sort of naturally partitioned or clustered. So there's clustering. You mentioned the clustering key, which essentially maintains a sorting order over the data. So if you read a narrow slice of that, then all the rest of the data, it's as if it wasn't there. There's sort of a very early metadata filtering part in the query that says, hey, what are the files, what are the pieces of this data that I need to read? And you only look at those files. And then so like, it doesn't really matter. Like you could have petabytes, you could have exabytes worth of data. It just adds a little bit more metadata. And so really kind of the interesting thing from the perspective of how your query performance and your query experience is how big is the data that you're actually querying? How big is the sort of the working set of your data? And I think that's sort of what even people who have giant data, they're very often their working set is much smaller. And I think the case you gave earlier where somebody setting a cluster key, they were running up massive bills. Likely their working set was actually much smaller, and they should have been that could have been done had they set the cluster key correctly. That could have been done using kind of small data analysis tools, and it would have been much less expensive.
Mm-hmm. Yeah, I see it a lot. I mean, you see it also with other tools like Snowflake. I think I've seen people do some wild stuff in there and rack up a pretty big bill, right? But I think, I think what's interesting too is the discussion that I'm seeing online now. It's turning to stuff like DuckDB. All of a sudden, like that's, I think obviously with the work that MotherDuck did over the past couple of years, it helped popularize DuckDB. But I think DuckDB on its own did a great job of popularizing it as well itself. But yeah, the discussion I'm seeing lately is more and more people are using it, as sort of a substitute. So like, why do I mean, one example I saw on Friday, one guy was like, yeah, I just put some data in Google Cloud Storage and just brought in DuckDB and did my thing. And I was like, dude, you could just use Google Drive too and just set up DuckDB and actually have a pretty sick system if you wanted to go that route. So what are you seeing with DuckDB?
So, I think DuckDB is being used in all these really interesting sort of nooks and crannies. We last week in Seattle, the DuckDB Labs co-founders came out and hosted DuckCon, and so heard a bunch of lightning talks and a bunch of talks by people that were kind of using DuckDB in all sorts of like interesting ways, like on the server to translate from like CSV to Parquet, or translate from one thing to another, or even just as a JSON parser. Because like if you can point at a JSON file and just you can easily parse it using SQL. It's sort of a nice kind of way to sort of pull out JSON fields into a table. Using it in R and Python and in notebooks and in BI and in data lakes and like just all sorts of interesting use cases, visualizations. It runs in the browser, so you can do some of these like 60 frame per second, video game style flying through your data becomes possible with something like something like DuckDB. And I think there's sort of if you've got a hammer, everything looks like a nail. But like if you've got a really good hammer, and like you can you can do a lot of interesting things. And I think it's people are just sort of finding new and interesting use cases for DuckDB. And I think one interesting thing that sort of relates to sort of data size is data lakes. Data lakes are sort of the prototypical. I've got tons and tons of data, because usually you throw data in a data lake because you don't want to actually curate it. You just sort of want to just throw a bunch of files in S3 buckets, and it grows and grows and grows over time. And DuckDB turns out to be a great way to query data that's in a data lake, because you can very often the actual amount of data you need to read is pretty small, and so you can run it from your laptop. You can point your laptop at query data over S3. And that's one of the things that MotherDuck also can help with, is we have cloud servers that are likely closer to to the data than you are. And may be able to scale up a little bit better. But there's also no reason not to just sort of run DuckDB on your own on Iceberg, or Parquet files, or or kind of however you have your data set up.
It's interesting you mentioned Iceberg, because I think that's obviously been in the news, namely because of the tabular acquisition of Databricks. What role do you see DuckDB playing in, maybe an open table format world?
Good question. I think the tabular acquisition by Databricks did throw a whole bunch of uncertainty in the world. My feeling was, in talking to practitioners and data people, that everybody has a plan to move to Iceberg. And so there's just an interesting thing, is that everybody has a plan to move to Iceberg, and then I also ask, well, how much of your data is actually in Iceberg? Oh, not very much. I think also there may be something under the covers that is slowing that down. But I also hear Iceberg a lot more than Delta. I know that I think probably from a technical perspective, I've heard technical people who are like that the Delta is really sort of well done, and I think Databricks is very happy with Delta, and so it'll be interesting to see what happens to those two formats. I can't imagine over time they're going to want to continue to support two basically overlapping formats, and my guess is they'll try to sort of merge them and maybe use their sort of uniform thing. But I know it'll be interesting to see how much data actually moves into these sort of data lake or lakehouse formats. But the cool thing for me is that if your data is in Snowflake or BigQuery or Redshift, and we as MotherDuck want to approach a customer and say, hey, you should try out our software, you should try out our tool. We think it's awesome, we can save you money, it's going to be faster, easier, et cetera. We have to convince people to kind of either export their data or write it in two places and try to manage it in multiple places. If the data is in Iceberg or Delta, then basically we have the same access to the data that anybody else does. And so, I think even at the Snowflake Summit, the Snowflake CEO said something is yeah, we think the Snowflake database is the best, and so come at us, bro. I think there's going to be people that they're going to take him up on that.
Oh,
yeah. So Snowflake is expensive. A lot of these other data warehouses are expensive. If you can start to pull workloads over to another tool really, really easily, without having to do export data or anything else. I think that there's going to be a lot of opportunity for other databases, other query engines to be able to sort of to have access to that data and to those workloads, and especially with things like SQL Glot that can do query translations. You don't even necessarily have to change the dialect that you're writing in to make it easier. And then I think beyond that, I think there's also just DuckDB. They did a really good job of making a they call it user-friendly SQL, and making the SQL easier to use, easier to write, easier to kind of great developer experience and user experience. And I think that's also going to help them win some workloads from for people that have data that's stored in Iceberg and Delta. I do think though there's still some more work needed on the connectors and performance work, and kind of there's some of that I think is coming in the next DuckDB version, which is in 2 weeks. And but I think more of that's gonna have to happen over time. Iceberg and Delta are reading them is pretty easy because you just have to sort of read an additional manifest file, and that tells you which files are actually active. Writing them is much harder. Writing them is basically you have to write a full-blown half of a database. And so there's a bunch more work that has to happen in order for that to work well.
That's really interesting. Walk me through this. I'm always curious about the competitive dynamics of running a analytical database company in the world today. It's from where I sit, it seems like it's I wouldn't say crowded, but there's definitely some strong competitive players out there. It is crowded too, but like how do you stand out in a crowded market like this, especially with something like MotherDuck, which is I would say very different from sort of the vanilla analytical engines?
I think in a couple different ways. I think one is there's just a lot of people who are frustrated about their costs. It's like one of the things about analytics is it tends to sort of usage tends to grow over time. And I think Snowflake for a long time had sort of investors loved Snowflake because they had basically super high net revenue retention, which means that if a customer spent $1 last year, they're going to spend $1.50 or $1.75 this year. And that's great for investors. It's less great for users who are going to have to over time, like you end up spending probably more than you intended. So I think that there's a lot of people that are sort of waking up and finding like, wow, this is like we're spending more than than the value that we're getting out of it. And I think so there's an opportunity to come in and with something that costs less. And I think that's something that we can do because of the simplicity of the architecture, the scale up versus scale out architecture, because of the sort of more modern database engine, because of hybrid execution, the fact that we can do work on the client side and we can push more workloads down to the client. We can do local caching, and you end up you don't have to pay for anything that that runs locally. I think there's a lot of opportunity for sort of dramatically less expensive. So I think that's one thing that we can certainly stand out on. Other things are just simplicity and ease of use. I mean, Snowflake is not hard to use. Like it's I think they did a great job. It's a great product. But there are some things that can be better. A lot of people end up spending a lot of their time wrangling CSV files. DuckDB has like an engineer writing, building the world's best CSV parser and writing research papers and continuing to push the art of like what you can do in a CSV parser. And it sounds silly because it's like, oh, well, you just do that sort of one time. And like, what most database people care about is like what happens inside the database. But if you also look at the amount of time that practitioners spend on like, oh damn, I have this file and like there's this
Yeah.
weird thing in the middle of it, or has uses this weird character for nulls, or it uh, it chokes on this CSV parser. Like that can be like really difficult and frustrating, and by like just spending that extra time and energy to make that work, then you just pointed a CSV file, it just it just works, you don't have to worry about it, and then you can join it against your other data. So that's sort of an example of things that like I think DuckDB does well. Other things that we're doing are like hybrid execution, which really can let you kind of blend local execution and execution in the cloud. And actually, we're calling it dual execution now because the sense that there's execution that runs on the server and the execution that runs on the client. And this can if you're running in Python or R or JavaScript, et cetera, we can some parts of the workloads can run locally, some parts can run in the cloud, and you don't have to really care about what runs where. We'll just make it run fast and make it run well. And I think that this turns out to be useful in a bunch of cases where you don't necessarily even have to know that this is what's happening, but like an example is in our, we actually just launched a Postgres connector,
I saw that. That's cool.
PG DuckDB. And so like the MotherDuck extension or MotherDuck kind of integration, will be able to, you can just join your local Postgres data versus your data that's in the cloud. And, or you can run a create table as select copies data into the cloud, or you can run data that copies cloud data, down locally, and it all just sort of works. And that sort of uses that dual execution, and we didn't have to build anything special for that. It just sort of works well.
What was the intention behind the Postgres integration?
So Postgres is having a moment. I think Postgres is sort of eating the world, and everything is there's just so many. So DuckDB right now is like has been shooting up the DB Engine's rankings, which is sort of like the baseball standings for database nerds, but I think and so DuckDB is like sort of like the fastest growing transactional database, analytical database. But Postgres is sort of the fastest growing transactional one, and it's also there's just a lot more people using transactional databases than analytical ones. And I think, and there's a lot of people using Postgres, and so there's probably I don't know a million developers using Postgres. And so if we can basically put DuckDB in their hands, or put the kind of the smarts from DuckDB into their hands. Oh, and by the way, if you want, you can also extend this into the cloud by using MotherDuck. We think that's a great sort of onboarding path for us. Distribution channel. At the same time, sort of getting back to the community, and sort of making something, making something that makes the world kind of work better, is to sort of add analytical capacity to Postgres.
That's super cool. It never actually occurred to me, because I saw it and I was like, that's interesting. And I've done a lot of work in Postgres over the years and absolutely love it. I'm glad it's having its day in the sun. Well deserved. The analytical thing is interesting though. Do you think that this will allow? I hate to use the term data products because it's very overloaded. But do you feel like this allows the opportunity for developers to start creating kind of analytical bolt-ons onto maybe the software applications in a seamless way? Or
yeah, so I think one big opportunity for MotherDuck but also for just this PG DuckDB extension is you're building an application, and that application needs to do something with data. And so how do you do that now? Well, you use either Elastic, or kind of you might use Snowflake, or you might use kind of just cache a bunch of things in Redis or something. It's sort of non-trivial to build an application that lets that shows even something like a leaderboard, without having to create special indexes, and it can just be more difficult. And I think this can just allow you to sort of build richer applications in general. The other thing you mentioned though is just sort of being able to bolt on additional things, which I think is actually one of the things that we haven't talked about yet about this PG DuckDB is that DuckDB, so Postgres has a great extensibility mechanism, and that's what we are leveraging. DuckDB also has a great extensibility mechanism. So one of the things you can do is you can actually use the PG DuckDB, which is a Postgres extension, but then you can add DuckDB extensions that do other interesting things that even can interact with Postgres. And so it's a little bit like sort of like Inception. It's like extensions all the way down. But I think that there's going to be some really, really cool things about, dealing with, Postgres storage and dealing with, with data lakes and indexing that, you're going to be able to build as a DuckDB extension. And the nice thing about DuckDB extensions is they can, dynamically load, they can auto load. And there's even sort of a community. There's community DuckDB extensions, so you can, that's something that the DuckDB folks launched recently, which is just kind of a community repository, and it's sort of like pip. You can add your own thing, so that people can just do sort of like from community and load X, and they'll have your extension. And so there's kind of going to be the ability to add those things to Postgres as well. And I think probably a lot of people in Postgres will not want this to happen. Like you're like, wait, you mean like people can like just load all kinds of random crap into our Postgres? Like you'll probably want to have some sort of way to sort of have an allow list, or kind of only these things are allowed, or a separate vetting process. But also it just really also opens up kind of the ability to really simply and easily add new high quality extensions that add significant functionality to the to the system. Like what's a good example? Somebody added like simple, it was like H3, which is like sort of the coordinate system for geospatial, like it's just a simple one that somebody can do on the weekend, but adds kind of actually useful functionality.
It's really interesting. Yeah, I have to noodle on this a bit, because I've been thinking about sort of just the roles of software engineers and quote data people, and how I sense that these roles are sort of merging in some ways. Like software engineers are going to be doing a lot more data workloads, and there's a shift left movement going on in data right now, where we need to work more closely with software. I'm kind of like, well, maybe they may end up doing very similar things. And then you throw in stuff like PG Vector, which is, I think, perhaps the most popular vector database right now. It's just Postgres under the hood. So it's interesting times.
But I think, in terms of the shift left stuff, or the I think one of the things we saw, with the rise of the modern data stack, was this sort of the supremacy of SQL, and all these people. If you can write SQL, you can do all this, with DBT, you can do all this data wrangling, and you can, kind of do a lot of, get a lot of stuff done that's not just sort of like building dashboards. You can also, the analytics engineer, and sort of that opened up a lot of doors for people. But I think there's something else sort of going on now, which is, especially because of the AI excitement and exuberance that we're seeing, like Python is really the lingua franca for AI. And I think, just as SQL is a lingua franca for data and data people, Python is a lingua franca for like people that are, stitching together AI applications and doing interesting things in the AI world. And so I think we're starting to see kind of a, tool chains come up, around Python. And it turns out that like Python and databases, are a little bit tricky. And this is one of the really great things, cool things about DuckDB, is that you can query because it's in process, you can query directly against your Python, your pandas data frames. You can query, directly against objects, using SQL. And so I think that there's going to be sort of a new class of kind of tools that will sort of be able to sort of merge databases and this sort of Python-based tool chain in order to help people build these AI applications. Or I think that's one of the kind of the key use cases that people have is like, hey, I'm a Python data scientist and I need to do a bunch of stuff with data. How do I do this? Oh, I need to install like DBT? Okay, I can probably do that, but there might be other ways that just sort of let them stay in kind of their kind of natural kind of how they think about the world, and they might need separate sets of tools.
Yeah. God, that's fascinating. I'll bring up something that's very not fascinating. It's a question I've had actually. So you have DuckDB over here, and so far we talked about SQL and stuff. But as far as I can tell, that the largest use cases of data are spreadsheets. Do you know of any work being done right now with DuckDB to integrate things like Excel?
One of the funny things is there's a DuckDB geospatial extension, and the geospatial extension included this library that can read a bunch of geo formats like Parquet and GeoParquet and like but one of the formats that it also could handle was XLS for Excel spreadsheets, and so people can read and I don't maybe even write Excel spreadsheets from DuckDB, and so it's kind of a neat hack. I think it's something that's actually worth kind of more investment, because it's as so much of the world's data is locked up in spreadsheets, and if you can pull data out of that, or pull or run DuckDB inside of Excel, like I think there's a bunch of opportunities. There's also a handful of new SaaS companies that are kind of that are sort of doing BI in the style of Excel. It's like, if you can do Excel, you can do BI. I think because some people do call it Excel is the world's most popular BI tool. Most people that are doing it wouldn't call what they're doing BI, but
I don't even think they know what it is half the time. I mean, my wife's in Excel every day, and she's like, I have no idea what you're talking about.
But if you're doing pivot tables, that's analytics, and that if you're doing like Excel charting, I mean, like that's kind of doing BI, and I think there's a bunch of opportunity there. But as much as ever, people try to kill Excel, like it still seems to be kind of firmly lodged in kind of just how people think about the world. Like,
it's like the Jason Voorhees of the data world. Like, you can kill it off. It comes back in the next sequel. So, like,
I just remember like after the like financial crisis in like 2006, 2008, like people talking about like, this multi-billion-dollar trading strategy was run by a single Excel spreadsheet by an analyst who fired, and now they have no idea how to like unwind any of their positions. And I think a lot of the world just still gets run by like random Excel spreadsheets.
Yeah. And I mean, when you mentioned small data, that's what got me thinking about this. And it's been one of these topics I've just been noodling on, because it's like we have all these fancy tools over here that do data. But then when you talk about small data, I mean, it's death by like a billion spreadsheets over here. And a lot of times these worlds aren't connected. And it's I don't know, to me, it's an interesting paradox. Just when you walk into most companies, you're like, the decisions may or may not be made by the analytical systems that we support. It's usually like you say, some spreadsheet that some dude wrote a while ago who's probably not even there anymore. So and it got me thinking, like, could DuckDB maybe power this behind the scenes? I don't know. It's interesting.
Could be. I mean, there's some cool things you can do. In BigQuery we had integration with Google Sheets.
Yeah.
And so like we had like Google Sheets that were backed by BigQuery tables. And there's like Equals, which is a SaaS company that is doing spreadsheets that can be backed by your Snowflake tables or MotherDuck tables or BigQuery tables. I think there are some kind of some neat things you can do that way. But I think also being able to take a DuckDB table and export it to Excel could be pretty interesting.
I guess we'll see. We'll move on to more interesting topics then. So you did mention AI. I'm very curious about your thoughts on the impact that AI is going to have or is having on, I guess, the work of engineers, data people, and so forth.
So pretty soon after ChatGPT came out, I talked to this guy. He was former Google brain person, he was teaching a course at Princeton, and he was teaching this data science course. And the data science course, he was not teaching people SQL. He wasn't teaching them Python, but he was having them basically extract a bunch of data from various data sources, crunch it, and then visualize it. And basically, the only thing that he was teaching them was he gave them all a OpenAI API key, and so people would basically use kind of natural language to generate Python code for data wrangling and then SQL code for kind of queries, and then I guess more Python code to do data visualizations. And this was pretty early, this was, I guess, 18 months ago. And when it just sort of struck me, it's like, wow, you can, a set of people who might have trouble kind of writing SQL or writing Python, are going to be able to use some of these, many of these tools. It's also kind of, there's this sort of the danger thing, which is you can get something really plausible and wrong very easily. And, you may not have the tools or the ability to sort of understand, why it's wrong. But you can have the sort of it looks entirely plausible, and you can have very high confidence in it. And then, I think also just, so I think AI is clearly going to change the world that, the data people live in. And is text to SQL going to replace, analytics and replace analysts? I don't think so. I think, I think that there's so much ingrained business logic in either in people's heads or in sort of, in the specific data sets, that it's going to be very hard for, an AI to know that okay, well, before 2021, we stored the data in a different format, and it's actually in this table over here, and and the way we calculate revenue. I'm just thinking about the way we calculate revenue at MotherDuck. We're a relatively early SaaS company. We don't have massive numbers of customers or massive amounts of revenue, and yet if I just want to know how much money are we going to make this month, it's a hard calculation, because there's different pricing plans, and there's just a bunch of things that are difficult about a lot of these calculations. And so while text to SQL can be good for very well behaved data sets and well curated data sets, it's I think in general it's hard to it's going to be hard to sort of really be able to make business decisions based on it. And I think that's the key. The thing that people want to do with data is they want to make decisions. But if you are not really sure that you're kind of standing on firm ground, then it would be pretty foolish to make strong business decisions.
Right.
Now, I do think that there's an opportunity for to build up semantic modeling layers and to create a semantic model that incorporates all what is revenue, or what is a customer, what is kind of these higher level things that can encapsulate kind of the quirks in the data model and the physical layer of the data model, and then allows you to ask, more natural language questions. I think that's something that is um, is something that is I hope to see happen. I hope to see happen. Not too long. I think there's a couple of folks that are building sort of some plausible modeling layers. And big fan of Malloy and with Lloyd Tab. Like a lot of the folks on that team are folks that we've kind of worked with, and Lloyd, the creator of Malloy, he named Mother Duck, and so have a lot of and he helped convince me to start Mother Duck in the first place. So
I didn't know that.
Yeah. You can blame him for for that if you need to blame somebody. But I think Cube's got their modeling layer. Transform, DBT has a modeling layer, and I kind of have high hopes that that we'll have a better representation of higher level representation of data. And then cool things can happen when you incorporate that into the database, is understanding can you actually build knowledge of that into the database, which is actually sort of one of the premises behind the Looker acquisition at Google, is that we were like really excited about the LookML, and it's like, hey, can we incorporate this into BigQuery?
Interesting.
But that ended up never panning out, possibly for like kind of internal politics reasons, but I won't comment any further.
As a very early Looker user, I definitely miss LookML. It was a lot of fun to write. So it solved a lot of problems. And I was glad to see that there were companies like Cube and DBT and others that are trying to split that out from the coupling with the BI tools. So we'll see where it goes. I mean, I'm writing a book on data modeling right now, which will be out later this year, hopefully. And it's interesting because the semantic layer is definitely, I think, it provides an interesting cheat code for because most underlying data models I've seen are pretty terrible for one reason or another. They start out with good intentions, and the road to hell is paved with those things. So that's a lot of databases right now. So yeah, I'm curious to see where it goes. How are you using AI in your day-to-day life? Do you use it at all?
So one thing in Mother Duck, we're using it in our UI to help make analysts better and help make it easier to write SQL. I think one of the ways we do it is just sort of by anytime there's a query error, we feed it through ChatGPT or GPT-4 and ask it to fix it, or ask it what's wrong, and it makes it a lot easier to write SQL if you can just sort of write what you think will work, rather than having to remember, okay, well, this is the order of anything that has an interval in it, it's like interval 3 days. Is it day or days? And then is it in quotes or not in quotes? And and is it the first parameter or the second parameter? You just sort of write what you think, and then fix it. We'll just fix it. And so it keeps you in a flow state more, rather than having to sort of toggle back and forth between the documentation. I think there's a bunch of stuff that we're planning on evolving that, putting a chatbot in the UI, et cetera, to be able to ask questions, and sort of, again, to sort of keep you in the flow state about if you say how do I the other one that I always have to look up is how do you do a trailing average using window functions, and sort of there's the interval 7 days preceding, it's kind of is it preceding or proceeding, and is there 2 E's in that, so can help out with some of those kinds of things. We're also kind of building in some AI functionality. So if you're an AI, if you're building AI applications, you can use those directly. I think one of the you mentioned PG vector, but I think one of the sort of frustrating limitations of vector databases is you sort of have to bring your own embeddings.
Yeah,
you kind of have to do all the translation of kind of your strings to embeddings, and that's expensive. You have to figure out which API to use, and kind of can be slow. and we just let you kind of do embeddings right within the database, and then you can do then you can do the embedding, vector comparisons inside the database to hopefully make that easier. And I think we'll be adding much more of these types of functions. And then I think more broadly, how else do I use AI? Like, I think it's, I don't use it all that much, but I guess the other thing is when I do like once upon a time I was, deeply technical, and then, I kind of don't get much time to do stuff anymore. And so AI is super helpful when I actually do get time to sort of do, try to solve a problem. There's a bunch of kind of context that I'm missing, or things that I forget. And it's really, really helpful to be able to sort of like to look up the Unix command, the shell commands to do something, or kind of the snippets of code that they can help connect to something else, or do something easy. I think people who are really, really good at like software engineers often find it's like not as useful, because they they don't need somebody telling them the parameters for X, Y, and Z. They just have have everything memorized, and they can get their job done. Anyway, that was a long-winded explanation.
No worries. Kind of closing out, like, what are you most excited about over the next year or two?
I think I'm just happy seeing things come together. I think that DuckDB has sort of gotten to a point where it is it's really good, and it's sort of reaching, like, I think you can sort of see actually in DuckCon that had sort of like crossed some sort of threshold from like being kind of this niche thing that kind of only a few people have heard about, is like saying to like a bunch of people, like really being a lot more mainstream. And I think once it becomes more mainstream, then all sorts of interesting doors and interesting things are gonna open up. And sort of I want to see what happens with DuckDB in the next year. I want to see what happens with the with Iceberg in the next year. I think there's a lot of big open questions about, like, are people actually going to move all their data into Iceberg, or is it going to be, are they going to run into problems? Who's going to win the catalog wars? I think there's some exciting, interesting things coming up. And then, the whole the data modeling and semantic modeling, like, is there going to be an emergent winner there? And because I do think that the ability to sort of raise the level of abstraction at which people operate is a huge opportunity. And I think we'll see how well that actually works.
Yeah, excited about those things too. Well, cool, Jordan. Thanks for the fun chat. I always learn a lot talking to you, so it's been a lot of fun. For people who want to learn more about you or what MotherDuck's up to, how can they do that?
So motherduck.com is our website. I'm easy to find on LinkedIn, and then my on Twitter, I'm just it's my name with the vowels removed, so it should be easy to find. Or you can come out to Small Data San Francisco on September 24th. And we're also doing a bunch of workshops for people who want to put together a bunch of these tools as well.
And I can vouch, MotherDuck parties are fun, so you should show up. You'll get maybe some duck swag too. So
absolutely,
yeah,
I can guarantee that.
Awesome. Well, cool. Great talking to you, man. Have a good day.
Thanks, Joe. Likewise.
Take care. Yeah.